Welcome to my channel Tic Tic Tac Toe. Today we will do another program on Java. You will find the problem statement in the description section of this video. First you try to solve this in your own, then view this video for solution. Now let's start. This is our problem. Write a program to declare the square matrix of order n. Check if the matrix is Doubly Marcov matrix or not. A matrix which satisfies the following conditions are Doubly Marcov matrix. That is, all elements are greater than or equal to 0, so there is no negative numbers, and sum of each row of this matrix will be equal to 1, and sum of each column of this matrix will be also equal to 1, not more than 1, not less than 1. So this is Doubly Marcov matrix. Accept n from the user where n is greater than equal to 3 and less than equal to 9. Display an appropriate error message if n is not in the given range or entered numbers are negative. Allow the user to create a matrix and check whether the created matrix is a Doubly Marcov matrix or not. So elements of this matrix cannot be negative numbers, and the matrix will be from 3 to 9, not more than that, the matrix order. So, and it is a square matrix. So let's start. First we will start from the main. So we will take the size of the matrix. So it is num. So we will construct an object with this num. So here we defined n and it is a float number, so it is from 0 to n. So each element of this matrix M will be between 0 to 1. So this will be float. So we take the float matrix M, and it is a square matrix 2D array. Now in the constructor portion we say that if the size is greater than 9 or less than 3, the system will output that the size is out of range, invalid entry, and matrix size must be greater than equal to 3 and less than equal to 9. Then the system will exit from this point. If it is within the range, then it will assign the value to n and initialize the matrix with order n. As it is square matrix, so both of this is n. Now we will read data. We will read data from the user input. So first we say that it will output that enter elements in the matrix. Then we have to enter the elements of the matrix. Now in the for loop we will take each number. So in this portion we will take the numbers from the user. Then int x equal to I by n, that is the quotient of this division. So this will be the matrix's row number. Then y be the modulo I modulo n, that is the remainder. So remainder will be the column of this matrix. So m x y equal to num. So we will take this input as giving enter one by one, but we will, based on the value of I, we will say that in which row and which column the number will be stored. So this is our storing process, and in this case we will show the matrix in matrix form. So it will show us the matrix in matrix form. Now we will check if it is Doubly Marcov matrix or not. So we will take j, an element for summing the columns. For k equal to 0 to n, k plus plus j of k, that means columns, all of the columns summation value is equal to 0, is initialized with 0. Now from j equal to 0 to n, j plus plus, k equal to the sum of each row. So k equal to 0, capital K equal to 0. Now for small k equal to 0, k less than n, k plus plus, first we will check if the number given is less than 0. So here it is the says that if all elements are greater than or equal to 0. So we will check if the element is less than 0. If it is less than 0, system will return from this and it will give the message negative numbers entered, invalid entry, and it will out from this program. But if it is not less than 0, is greater than or equal to 0, then it will sum the row. So for each row, k equal to k plus this element m of jk. So k equal to 0 in the first row first. So k equal to this will give the summation of each row. So it will be a float value summing the float values of each row, and it is stored at this, and you can check for each of this case if k is not equal to 1, then return from this function. So we will check that if summation of each row is equal to 1. So here with k we can check if summation of each row is equal to 1. For summing the columns, we have to maintain an array. So j of k, that means when column is 0, then we will take this j of k. At first it is initialized as 0 plus this value. When it is again, when j equal to 0, k equal to 0, it will take the value. Then when j equal to 1, k equal to 0, it will take the value. J equal to 2, k equal to 0, it will take the value. So for each of this row, for this array, it will sum the value of the addition of the columns value. So here we can check that in after ending this row columns, ending this rows iteration, we can check if k is not equal to 1, then return 1. After the jth iteration, we can check if for each of the value of this array, if each of the value is not equal to 1, then also return 1. It will check if the column's value is equal to 1 or not. So this condition, if each of the columns value is equal to 1 or not. So after getting out of this jth loop, we have to check that value of each column, summation of each column is equal to 1 or not. If not, then return -1. Otherwise, if this condition, one of these condition not happens, then it returns 1. That means there is no problem, then return 1. So in main, we after creating the object, we have read data. Then if check Doubly Markov matrix is equal to 1, that means no problem is occurred, then we will print that it is a perfect Doubly Markov matrix. Otherwise it will print it is not a Doubly Markov matrix. So this is our program. I think you all understand. Now we will show with example. We giving the size of the matrix as 3 Now elements in the matrix are 0.5, 0.25, 0.25, 0.25, 0.75, 0.0, 0.25, 0.0, 0.75. So now the matrix is look like this: first row first column, first row second column, third column. So we can see that summation of each column, that is 0.5 plus 0.25 plus 0.25 equal to 1, 25, 75, 1 plus 0, 1, 25 and 75, 1, and for each column it is 5, 25, 25, that means 1, 25, 75, that means 1, 25, 75, that means 1. So it is a perfect Doubly Markov matrix. Now if we give another error example, that means it is 3, now elements in the matrix are 1.5, 3, 0.15, 0.25, 4, 1.0, 0.25, 3. So this is our matrix. So here we can see that all of the value are is the summation of all of the row and all of the column is greater than 1. So it is not a Doubly Markov matrix. Now if we give the size of the matrix as 2, so it will print size is out of range, invalid entry, as we have to give the input from 3 to 9. Again, if we give here 3 and we give here the value 0.25, minus 2, 0.25, 0.25, 0.5, 0.75, 0.22, 0.15, 0.23. So here negative numbers entered, invalid entry. So it is not a Doubly Markov matrix. So you can see that this is our program and we have run with the examples output. So I think you all understand the solution. Let me know the problems you faced when you try to do this on your own. If you find this video useful, subscribe to my channel and share the video with your friends. Thank you for watching this video.